Hey there guys, it's Mrs. Rubery and we're going to review analyzing data. The first thing we're looking at is measures of center. There are three measures of center. They're the three M words, the mean, the mode, and the median. The mean is the average of the data set. That's where we add and divide for the mean. So you add up all the data and divide by the number of pieces of data. The mode is the most occurring number in a data set. Mode and most both have four letters and begin with an MO. Something to keep in mind is that there can be more than one mode or there can be no mode. And lastly, the median is the middle number in an ordered set of data. If there's no middle number, we take the two numbers on the edge of the median, add them together and divide by 2. We find the mean of the two medians. We also have measures of variance. Variance is variety in the data. One way to look at the variety of the data is the spread of the data or the range, which is the difference between the highest piece of data, the maximum, and the lowest piece of data, the minimum. Difference means subtract. And lastly, we have the MAD, the mean absolute deviation. This is the average of the distances each piece of data is away from the mean. It basically tells us how consistent the data is. Going to skip that time to climb. All right, so when we're finding the mean, median, mode, range, and MAD, no matter what we're doing, we always want to organize our data from least to greatest. So I'm going to organize this 2, 3, 3, 4, 4, 6, 7, 8, 8. And by the way, you can pause the video along the way because I'm going to try to go through it fast. You can pause it and then figure it out on your own. So for the mean, we need to add all our data together. When you add it together, you get a sum of 45. And we're going to divide that by the number of pieces of data. And in this case, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces of data. And 45 divided by 9 gives us a mean of 5. When we go to find the median, we cross off our highest and lowest in effort to find the middle. And in this case, our median is 4. In order to find the mode, we look for the most occurring number or numbers, if there are any. And in this case, we have a 3, a 4, and an 8. So all three of them occur twice. And lastly, we have our range, the difference between our maximum, in this case 8, minus our minimum, which is 2, which gives us a range of 6. We'll get to MAD a little bit later. Let's check a set of data that doesn't have a middle, so we have to do an extra step. So put them in order, 2, 4, 5, 8, 8, 9. When I'm finding the mean, I add them all together. I get a sum of 36, and I'm going to divide that by, in this case, 6 numbers, which gives us a mean of 6. For our median, when I cross off and try to find the middle, I find that it's between the 5 and 8. So for that median, I need to add the 5 and 8 together to get 13, and then divide 13 by 2 to get the median. So 6.5 would fit right there in between the 5 and the 8. The mode, again, is the most occurring piece of data. In this case, there's just one. It's an 8. Keep in mind, there can be no mode as well. And then lastly, the range is the difference between the highest, 9, and the lowest, 2. 9 minus 2 gives us a range of 7. Skip the time to climb. And let's take a look at mean absolute deviation. So when we're finding mean absolute deviation, the first thing we need to do is find the mean of the data. So I already have the data on this chart. And the mean of this data is 6. If you add it all together and divide, we get a mean of 6. The second step in the second column then is to figure out how far away the mean is from the data, and we can do that by subtracting. 6 minus 3 gives us a distance of 3, and we're going to continue to subtract the mean minus the data to get our distances. Now you're going to notice when I get down here like to 6 minus 7, the distance would be negative. But distance is never negative, and it's called mean absolute deviation because we're taking the absolute value. Once I have all those distances, my last step is to find the mean of the distances. So you get MAD, mean absolute deviation, when you have to find the mean twice. You found the mean of the data, and then you have to find the mean of the distances. So to do that, I'm going to add them all together, and in this case, I get 12. Divided by 6 pieces of data gives me a MAD of 6. We'll look at one more example. Here it's not all done for us. So I have my data listed there on the left. I'm going to find the mean of my data by adding it all together and dividing by, in this case, there's 6 pieces of data once again. And you can pause to find it. I got a 9. Now we're going to figure out how far away the data is from the mean. So 9 minus 1, that piece of data, gives us a distance of 8. 9 minus the second piece of data, which is an 8, is a distance of 1. 9 minus 11 gives us a negative number, but remember distances are always positive. So all of these 9 minus 11s are going to be a distance of 2. And then lastly, 9 minus 12 would give us a distance of 3. So I found my mean, I found my distance, and now I find my mean again. So we need to add all those together and divide by 6 pieces of data. When I add them, I get a sum of 18 divided by 6 pieces of data gives me a MAD of 3, mean absolute deviation. Okay, we're going to shift gears to looking at if data is skewed or symmetrical. This is called the distribution of data. When data is skewed, it's stretched out one way more than the other. When data is symmetrical, it's stretched the same distance from the median to the minimum and maximum on both sides. So when we're finding out the distribution of data, we first mark the median of the data and then look at the distance from the median to the maximum and the distance from the median to the minimum. If the distances are equal, the data is symmetrical. If it's longer and stretched out from the median to one of them or the other, then the data is skewed. The other thing we're looking at then, once we figure out the distribution of the data, what is our better measure of center? If our data is skewed, we're going to want to find the median as the better measure of center. Because when data is skewed, that means that it's getting pulled down or pulled up. And a low piece of data or a very high piece of data is going to throw off the mean. So therefore, median is better when data is skewed. If the data is symmetrical, then the mean is the best thing to use. So let's practice that a little bit. So here we have a line plot. Remember that a line plot, each dot represents one piece of data. And just to review, getting the data off of here, I'm going to look right at my number line, and I have one dot at 20, so I can list 20 as my first piece of data. Then I have 2 dots at 25, so I have a 25 and another 25. We have 3 dots at 30, so we're going to list 30 3 times. 1 at 35, 1 at 75, and lastly 1 at 85. So I listed my data. The range of my data is going to be 85 minus 20, which gives a range of 65. The mode of my data is the most occurring, and I have the most 6s of anything. So the mode of my data, I'm not 6s, 30. Sorry, my iPad was glitching. Still is. So that would be 30, mode of my data. The median is going to be the middle piece of data, which in this case is 30 again. Sorry for the glitching. And lastly, my mean, if I add everything together and divide, in this case, I'm going to add it all together and divide by 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces of data, which gives us a median of 39.4. And it's coming on slowly there. So let's talk about the distribution of the data. So the distribution of the data is the distance from the median. So our median was 30. I like to draw a vertical line up through the 30 like that. And then see, is my data pulled more towards the 20, my minimum, or pulled more towards my maximum of 85? And you'll see it's pulled more towards the maximum of 85. So we say that this data is skewed to the right because it's going up more to the right. And Nearpods are really giving me some trouble here. And then finally, is the mean or median a better measure of central tendency? because the data is skewed, we would say the median is a better measure of central tendency. And let me try this. Looks like Nearpod's not cooperating. So I'm going to stop my video there and then have a part 2.